This lesson is connecting all that we've learned about slope variation and first differences. There are many ways that we've learned how to represent linear relations, how to read linear relations, and how to display linear relations. We've learned how to identify slope and our y-intercept values in words, in a graph, using numbers, and reading and creating equations. What we're going to be doing is reviewing everything that we've learned through various examples of linear relations. Example 1, fuel consumption. The graph shows the relationship between the volume of gasoline remaining in a car's fuel tank and the distance driven. We can see from the graph that our line is falling to the right, which means that it has a negative slope. Remember that when we're calculating slope in part A, that your answer should be negative. I'm going to use the slope formula to find slope. I'm going to first pick 2 points. I'm going to pick 0.65 and I'm going to pick 239. I'm picking points that are on the grid lines that are easy for me to read. 0.65 will be my x1, y1 point, and 239 will be my x2, y2 point. I will write out the formula. Then I will substitute my values. And reducing my fraction to lowest terms. And notice that I did get a negative value in my slope, which is correct because my linear relation is falling to the right. The second part of part A asks us, what is this as a rate of change? Remember, the rate of change is slope in decimal form with units. Using my calculator, I'm going to type -13 divided by 100, which is equal to negative 0.13. And I'm going to include the units, kilometers and liters. And I'm going to write my dependent variable units first. Liters per kilometer. Therefore, for every 100 kilometers driven, that's my denominator of my slope. You lose or use 13 liters of gas, which is why we get a negative, and it's my value for my numerator. So -13, you're losing 13 liters of gas for every 100 kilometers driven. Determine the y-intercept. Remember that your y-intercept is your y value when x is equal to 0. And we can just read that value here on the graph. So our relation intersects with the y-axis right here. So when x is equal to 0, y is equal to 65. B is equal to 65. Our y-intercept, B, is 65. Therefore, the car initially had 65 liters of fuel in the tank at the start of the road trip. Remember, the word initially, means your B value. Now we're going to create an equation. Referencing my graph again, I want to make note that instead of y and x, they've already given us two variables that they're using. So instead of y, I'm going to use capital V, and instead of x, I'm going to use lowercase d for variables. So my equation is going to be in the form V is equal to md plus b. We found our slope, which is negative 13 over 100, and we found that our b value was 65. I'm going to leave v and d, my dependent and independent variables, as variables, and we've just created an equation. Now, since our b does not equal to 0, I know that this is partial variation. You are driving to a friend's house who lives 44 kilometers from your house. Assuming you started with the original 65 liters of gas, how much gas will be remaining upon arrival at your house? How much gas? That's what we're trying to find. Referencing our graph again, how much gas? That is our volume or our dependent variable. And it tells us that we drove 44 kilometers, which is our distance or our independent value. Beginning by writing out my equation that we just created. I'm going to substitute 44 where I see D. And I'm solving for V, how much gas. Following BEDMAS, I'm going to simplify my multiplication before I add that 65. Negative 13 times 44 is negative 572, and we're dividing that by 100, and then we'll add 65 to it. Negative 572 divided by 100 is negative 5.72 plus 65 is equal to 59.28. Therefore, there will be 59.28 liters of gas remaining upon arrival. And one more thing to note is to always include units. This question was presented to me in words, so it's important that I answer it in words using a therefore statement. A scientist researched levels of motivation in relation to hours of sleep. They were able to determine that patients who slept less also had less motivation to eat, work, or participate in any activities. They were able to model the relationship with the equation y is equal to 5x plus 10. Now we're going to create a table of values just given the equation. But that's all I really need. In this equation, I'm given everything that I need to create a table of values and to graph the relation. I'm given my slope, which is 5. I'm also given my b, or my y-intercept. All I need is my slope and my b in order to create a table of values. So remember that your left column is always your independent variable, and your right column of a table of values is always your dependent variable. Now, in this question, we're comparing the number of hours of sleep to levels of motivation. So, the number of hours of sleep you get is your independent variable because it affects your motivation. Your motivation depends on how much sleep you got. When creating a table of values, I'm always going to start with my x value of 0 in order for me to then plot my b value here. Then, to make it easier for myself, I'm just going to increase by 1. So when x is equal to 0, y is equal to 10. And I know this because my b value is 10. Using my slope, I'm going to increase my y values by 5. So when x is increasing by 1, y is increasing by 5. When x is increasing by 1, y is increasing by 5. When x is increasing by 1, y is increasing by 5. Now we're ready to graph this information on this grid. I've labeled my axes and titled my graph. Now I'm ready to plot my points. 0, 10, 1, 15, 2, 20, and 3, 25. Using the graph, how many hours of sleep would a person need to get to reach a motivation level of 50 vibes? So motivation level, that is your y value. So y is equal to 50. It's asking how many hours of sleep. That is your x. Finding x. Remember that we were provided the equation at the beginning of this question. So I can use that equation, y is equal to 5x plus 10. I can sub y is equal to 50, and I can find x. So 8 is equal to x, which means that you would need 8 hours of sleep in order to have motivation level of 50 vibes. So that means that 850 is also a point on this relation. So if I extended my relation, it should meet that point, and it does. Next example. Jackie earns $25 per day plus $9 per 100 flyers for delivering advertising flyers. This is an example of using words to describe a relation. The relation can be also described in other ways. Using numbers. Create a table showing Jackie's daily earnings for various numbers of flyers. So remember, when you're creating a table of values, you're going to begin with your X values, or in this example, your F values. And you're going to start with 0. And this time I'm going to increase by 100 because it tells me information for every 100 flyers that Jackie delivers. So I know that Jackie earns $25 per day no matter how many flyers are delivered. So this is a fixed cost. That will not change. That is my B. So even with 0 flyers delivered, Jackie earns $25. It also tells me in the question that Jackie earns $9 for every 100 flyers. So for every 100 flyers, Jackie earns $9. 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 Let's determine our slope. I'm going to use my change in y over change in x formula. So my y is changing by 9, while my x is changing by 100. I can't reduce this fraction any further, so that's my slope, 9 over 100. In rate of change, I would just include units, and I would convert this into a decimal. 9 cents per flyer. On the next page is asking us to graph this and to create an equation. I can create an equation first. We know that our slope is 9 over 100 and that our B is $25. Using the table of values, I'm going to plot my points. 0, 25, 100, 34, 200, 43, 352, 461. And writing my equation to label my line on my graph. A local theater is hosting the musical Cats. In order to perform at the theater, the Cats musical company must pay a royalty fee of $1,250 plus $325 per performance to the theater. So already I know that the royalty fee is my fixed cost, my B value. That doesn't change. No matter how many performances they put on at the theater, they have to pay that royalty fee. And then they also pay $325 per performance. This is my variable cost, or my slope. The same theater is also hosting the musical Fame. The musical company of Fame has to pay a royalty fee of $1,400 plus $250 per performance to the theater. So this fixed cost is $1,400, or B is equal to 1,400. And $250 per performance. That is the variable cost. Or M is equal to 250. Create equations for both musicals. So I know that since I have a B value for both musicals, the equations to represent them is going to be in partial variation, y is equal to mx plus b form. For Cats, the slope is 325 and b is 1,250. For Fame, my slope is 250 and my b is 1,400. Create a table of values for both musicals. So my independent variable here is the number of shows that each musical will perform. And the dependent variable is the total cost they will pay. And remember to start with your x values with x is equal to 0, and I'll increase by 1 show. My B value for Cats is 1,250, and my B value for Fame is 1,400. Using my slope, when x is increasing by 1, y is increasing by 325 for Cats. When x is increasing by 1, y is increasing by 325. When x is increasing by 1, y is increasing by 325. When x is increasing by 1, y is increasing by 325. For fame, when x is increasing by 1, y is increasing by 250. When x is increasing by 1, y is increasing by 250. When x is increasing by 1, y is increasing by 250. When x is increasing by 1, y is increasing by 250. Next, we're going to graph both of the musicals on this grid. Now it's time to plot my points. I'm going to plot Cats in red. 0, 1,250. 1, 1,575. 2, 1,900. 3, 2,225. 4, 2,550. And fame, I'll graph in purple. 0, 1,400. 1, 1,650. 2, 1,900. 3, 2,150. 4, 2,400. And make sure to label your lines when you're graphing more than one on a grid. At how many performances will both musicals pay the same amount to the theater? Well, we can reference our graph and we can also read it on our table of values. Remember from last lesson that the point of intersection actually provides us with this information. It tells us that at this very point, 2, 1,900, both musicals will be paying the same amount. So at 2 shows, they will both be paying $1,900. Going back to my table of values, they both share that same point on the table of values. Last example. Manny is running a race at a constant rate. Already I know that this is going to be linear because it tells me that it's constant. He records his distance from the starting line at various times shown below. Complete the table. So there's some blank rows and there's also some rows missing. Let's try to find the relationship between T and D. I'm going to determine the relationship between D and T from these two rows because I know that when T is equal to a value, it has the completed D value here for me. The other rows are not completed. So it would be difficult for me to determine the relationship between T and D in the other row. So I'm going to work with these two. So from this X value to the next, X is increasing by 0.5. And my Y is increasing by 3.5. So when X is increasing by 0.5, Y is increasing by 3.5. So that's the relationship. So I can use that now to complete some of the other rows. So when X is increasing by 0.5, I know that Y is increasing by 3.5. So 3.5 plus 3.5 is 7. Okay, and so I'm going to use the same pattern here. So when X is increasing by 0.5, just working backwards, this would be 0. Y would also be increasing by 3.5. So working backwards, adding 3.5 to get 3.5, that means that this would be 0. So there are some rows missing, and I can tell because we're no longer jumping from 2 to 3. That's not a 0.5 jump, or 3 to 5. That's not a 0.5 jump. So we need to use our slope in order to help us complete the rest of this table. So let's determine our slope on this side. Using my change in y over change in x formula, my y's are changing by 3.5 while x is changing by 0.5. Dividing that, m is equal to 7, which tells me that for every 1 hour running, Manny travels 7 kilometers. So when x is increasing by 1, y is increasing by 7. Jumping to the next row, this is increasing by 2, which means we need to double 7. Because we're doubling x, we have to double 7. Now it's asking us to create an equation. I know from my table of values that this is direct variation because when x is equal to 0, y is equal to 0. I'm also going to use t and d as variables instead of x and y. D is equal to my slope we found, t. And finally, it's asking us to graph this relation on the grid. So using the points in my table of values, I'm going to plot 0, 0, 0.57, 0.5, 3.5, 1, 7, 1.5, 10.5, 214, 321, and 535. And I'm going to label this with my equation. A good way to tell if you did complete the table of values correctly is if your points create a straight line when you graph it. And mine does, so I know that I completed the table of values correctly. There are some homework questions here for you to consolidate all of your learning from this unit. Great job today.